Hi guys, today we are solving this problem called rotate image. This is a medium problem and this has been very frequently asked in interviews. This is marked as a medium problem but is kind of easy. And there is one trick to do this problem which we are going to learn just now, and we have to remember it during the interviews because this is something that you cannot come up with if you're doing it for the first time. So you have to keep this in mind. You are given an n into n 2D matrix representing an image. Rotate this image by 90-degree clockwise. You have to rotate this image in place, which means you have to modify the 2D input matrix. Do not allocate another 2D matrix to do the rotation. So this is the given example. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, and we have to rotate it by 90 degree. So which means this should come here, this should come here, this should come here. So to do this, to think of it logically is very simple, but when you try to do it, it's difficult. So what are we going to do is we are going to transpose the matrix first. So let's see what will happen if we transpose the matrix. If we transpose the matrix, it will become what does transpose exactly mean? Transpose means that whatever is the whatever is at ij's location will become jith's location, which means if we have 1 here, it is going to remain there because I and j are same. If 4 is here and 2 is here, so we are going to swap these elements. 5 is going to remain there. 7 and 3 are going to interchange their positions. 8 and 6 are going to interchange their positions. So that exactly is transpose. So what exactly will happen then is 1 will come, 1 will stay there, 4 will come here, 7 will come here. Then here we'll have 2, 5 and 8. Here we'll have 3, 6 and 9. So this is what will be the output of transposing it. And after this, what we have to do is we have to rotate it. By rotating, what do I mean is if your element here is 1, it will be swapped with element at the if the element is at the leftmost corner, it will be swapped with the element at the rightmost corner. And similarly, till I and j becomes equal. So here the output would come 1 will be swapped with 7, so this would become 7 here. 4 will remain there itself. Similarly, 8 and 2 will swap their positions. 8, 5, 2. This would be the output. And here, 9 and 3 will swap their positions. 9, 6 will remain there, and 3. So as we can see, we have achieved our final output, which is similar to the given matrix. So this we achieved by transposing it. I'll just write it here. First, we are going to transpose, which means I will just write it down here below. I'll have another. First, we are going to do transpose, which means I swap, which means ij swap with ji. Then what we're going to do is reverse, which means ij swap with I n minus j minus I. So this is the most important part which you have to remember. And there is one more thing which you have to remember, but we'll get to it while we are solving the problem. So this is what you have to remember. If we do both of these things, then we have our final output, which is the 90-degree rotation. So I hope this is clear. We'll just put this to side. Just a second. So now let's start coding. What we are going to do is we are going to do exactly what we just discussed. We are just going to create n and m. n would be the maximum length, we could just take n and not even m, because both of these are same, which means it is going to be a symmetric matrix, which means the number of rows is equals to number of columns. So we can just take n or length, whatever we want to take, which will have length of the matrix dot length. Then what we're going to do is we're going to have a general basic traversal of a matrix, which is by having two for loops. Int I will start from 0, I is less than n, I plus plus. Then here is the catch. While the second for loop, we are going to start from I and not from 0. And why is that? Because we have to transpose it. If we are at a position ahead of I, then we'll have errors, and the error would be a logical error, not a runtime or a compile time error. It would be a logical error. So we won't prefer having such errors. So we just start J from I. And after this, we're going to have a normal swap, which we just wrote here. In transpose, this is the transpose. This is the first part where we do transpose. And after this, we are going to have reverse. So let's write this. We all know the general swap syntax, which is matrix of I, J equals to matrix I, J equals to matrix J, I. Wherever we have I, J's location, we are swapping it with J, I's location. Matrix J, I equals to 10. So this is it for this for loop. For rotation, for reverse, we just copy this and edit this one only. Here we start J from 0 because we have to change a few things in this, which is we are going to change matrix Ji with I n minus j minus 1. N minus j minus 1. We just copy this and just paste it here. Let's see if this runs. Let's remove our annotations so that we have a better idea. The output which we want is different than what is expected. So let's see what is our error. Here it should be n by 2. Let's run it now. Our output is correct. So this is the logic which you have to remember. The main highlights of this are that we have to follow the steps such as first would be transpose. In transpose, we have I starting from 0 and J starting from I. Then in rotation, which is a reverse, we have I and J both starting from 0. But in place of I, J swapping with Ji, we have IJ swapping with I and n minus j minus 1. Also, j runs less than n by 2. This is what we have to remember, and this is logically also very clear, which we just tried to do. That is transposing the matrix. So this logic is exactly what is used to transpose, and this is exactly what is used to reverse. Let's try to submit this. The solution is accepted. I hope you guys understood. I'll see you again tomorrow. Thank you.